One of the big challenges when we try to find out information below sea level is to be able to see everything. It's really difficult to map areas that are important benthic areas, like bottom areas, like the seabed, to find out which habitat is best to protect endangered species or to house really diverse areas. It's really difficult to find those out. And a lot of times it's expensive to pay for remotely operated vehicles or deep sea submarines to be able to go out, or even scuba divers to be able to go out and map the areas. Sometimes you're limited by area, you're limited by people power. It's very difficult. But here's an idea. What if you use animals to map those areas? Well, that's what we're going to talk about on today's episode, because a new study has revealed sea lions have been used to map benthic habitats in Australian waters. We're going to talk about that on today's episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin, and this is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, what you can do to live for a better ocean by taking action. And on today's episode, we're going to be talking about something that I have always been interested in. That's mapping the ocean. Finding out as much information about the ocean so you can do more analysis and be able to protect the ocean better. It's how to protect the ocean. I wonder where we got that idea from. Anyway, just to give you a little background, growing up as a marine biologist after my undergrad and doing my master's, when I did my master's, I was introduced to a technology called Geographic Information Systems. It's also known as GIS. If you don't know what that is, it's essentially a way to house information in a database with a GPS, basically a location. And so a lot of times when you're in the field and you're trying to map things, you're trying to find out things like, where are the coral reefs? Where are the seagrass habitats? Where are the mangroves? How far do they reach? How far do they go? How deep do they go? And where can we find animals that are associated with that? And can we map and predict where these habitats will be based on specific environmental conditions and sort of topography, like geography and geology and all that wonderful stuff? And so I learned that in my master's. In fact, normally when you do a research master's, I remember you do 2 to maybe 3 years at a school where you just do some field work, you run some analyses, you learn some new techniques, you get to interact and network with a number of different professors, people on your committee. You have to do testing, then you have to defend, and it's a big whole ordeal. Mine was a little bit different. I didn't do my full 2 to 3 years at my university, at Acadia University, at my graduate university. I actually did 1 year at the Nova Scotia Community College to learn about GIS. I was in their geomatics department, and I learned about GIS and remote sensing. And when I learned about that, I was really interested in learning about how to use these technologies to map, benthic habitats, essentially the seafloor. No matter how deep it is, how do we measure that? How do we find out what's there, especially when it comes to fish, macroinvertebrates like crabs, shrimp? That was macroinvertebrates were really my master's thesis. That's what I looked at. And I looked at, what different assemblages were there, what different communities of macroinvertebrates were there along the Scotian Shelf, Nova Scotian Shelf, and Bay of Fundy. And did they repeat? Did they typify an area? Were they all found in one specific area? There were 4 to 5 areas that were found over 4 years consistently. And how would that play a role in marine protected areas? But I digress. That was my master's thesis. If you ever want to talk to me about that, I'd be more than happy to go over that. That was it was 20 years ago this year. Crazy how long ago that was. But I digress. I did my year at the Nova Scotia Community College in their geomatics department, in their geomatics school. And then I did a year at my master's university, Acadia University. And I was able to defend successfully that master's. So I came out and I had a GIS background, and I started to explore what that meant and how I can use that for a lot of different analysis, from creating maps to looking at spatial analyses of communities. It was a lot of fun. And that continued to persist as the technology got better. We started to get remotely operated vehicles, and we started to get data from that. But the problem with those remotely operated vehicles is they were super expensive. We even had not only underwater, but we had above water. We had LiDAR, which was just like a new technology back then, which was even more expensive to use, but it gave you like the benthic like the depths of things underwater at a certain depth. You know, it's pretty shallow, but you got to see the shoreline quite a bit. You got to be able to make predictions of what those areas would be based on depth, based on what's found there before. But it was really cumbersome. It was expensive. You had to have a lot of people on the ground to be able to ground truth certain areas. It was a difficult process. It wasn't easy. And the ROVs, like using them was a lot of fun, and you go to school for that, and you can do that. I've never actually operated one, but I saw them being operated. I see people get this type of benthic data, but they were in very small areas, and it was very difficult to cover a large area because it was so expensive. I don't know how expensive they are now, but I'm sure they're still more expensive than we would like. So it was difficult even though you had the technology to do it. Now you have drones, and you have specific satellites that can go in centimeters resolution, so you may be able to tell different coral reefs apart. You'll be able to tell some coral reefs from seagrass areas, from mangroves, and all this different stuff. But it's a heavy burden to take. You have to be very technical. You have to know a lot about wavelengths and different narrowed resolutions and all this wonderful stuff, when satellites are going to pass, how to get rid of cloud cover. If you can get rid of cloud cover, it's a lot. It's a lot of math. It's a whole field in itself. But when you want to use it for conservation, you want to be able to use it so it's effective in your decision making. And so some researchers did a study in Australia where they decided to say, hey, you know what would be a really good idea is if we used animals for this type of stuff. Now, I want to talk, just before I go into the animals, I want to just talk a little bit about tagging. Tagging has been really a really important technology, having satellite tags and small pit tags to be able to tell the distribution of a population of a species. So in other words, where do they go, how far, how long, sometimes how deep, what's the temperature salinity, depending on what's associated with the tag. And you're able to be able to see where they go in terms of from a location. Like they'd have a satellite GPS, or they'd have a pit tag GPS where they pass these receivers, and they'd be able to tell where they are and when they passed and what individual and all that kind of stuff. And that was great. That was awesome. But now we have something different. We have tags, but they're called camera tags. And camera tags allow us, the technology is that good where it allows us to mount a camera on an animal, whether it be a shark, a whale, any kind of marine mammal, and you get to see where they go. In fact, there's been some pretty interesting discoveries. Over at Beneath the Waves, Dr. Austin Gallagher and his crew were able to find out where one of the largest, I guess you call it patches, but habitats of seagrass are in the Bahamas and potentially in the world. And they were able to discover that by putting a camera tag on a tiger shark, an animal that they study regularly, and being able to see where it goes and how it goes. You may not have saw that or seen that if you just looked at a GPS, if it was just a regular tag without a camera. But now that you see a camera, you get to see visually, you get to see the bottom, right? You're not making predictions. You're not diving on. You get to see the bottom from the perspective of the back of a tiger shark. Well, a group of researchers in Australia decided to do that, but they're going to hey, you know what? There's this endangered sea lion that we really want to protect. Let's find out where it goes. And while we're doing that, let's map the habitats of where it goes by putting a camera tag on it. Wow. If you said that to me 20 years ago, I'd be like, that's crazy. You're going to lose the tag if that even exists. Like tags were just new back then. I'd be like, there's no way that that's going to work. No way. Well, it worked. Not only did it work, but it worked really well. They tagged 8 endangered sea lions, and it kind of unravel the mystery of some of the bottom areas that they were able to go into and that they were able to find, some of the areas that they were finding, and map about 5,000 square kilometers of seabed in southern Australia. Now that is something that is pretty cool. And they were able to get critical information that provided management to protect an endangered species, but could also be used to survey other marine species of interest. So, whatever species that they find in that area. So the Australians have now enlisted endangered Australian sea lion, so Neophoca cinerea, that's the Latin name, I'm not trying to swear on this, to carry cameras. So the resulting videos allowed researchers to identify previously unmapped benthic habitats used by the sea lions on the continental shelf. They published their results in Frontiers in Marine Science. So using animal-borne video, is a quote, using animal-borne video and movement data from a benthic predator is a really effective way of mapping diverse. Author Nathan Angelakis, I'm not sure how to pronounce that, a PhD student at the University of Adelaide and the Southern Australian Research and Development Institute of Aquatic Sciences. He said these data are useful both for mapping critical habitats for an endangered species, such as the Australian sea lion, and more broadly for mapping unexplored areas around the seabed. Now think about this. You don't know where this animal goes. You put this camera tag on the animal. You don't know where it's going to go. But you also want to know where it's going to go, and you know it's going to be a mystery, so you're tracking these animals. Not only are you tracking these animals, but visually you're able to see what habitats the animals go, right? So for the project, 8 adult female Australian sea lions from Olive Island and Sea Bay colonies were equipped with small, lightweight cameras. So it's so light that they didn't want to affect the drag of the swimming, so they made it really, really light. The cameras and tracking instruments were glued to small pieces of neoprene that were then glued onto the fur of the sea lions, which doesn't harm the sea lions. So in total, the filming and tracking equipment weigh less than 1% of the lion's body weight, the sea lion's body weight, to prevent dragging effects and allow the animals to move without restrictions. Recordings were made over 2 to 3 days, and they had over 89 hours of recordings. It was actually quite amazing. Now what they're able to do is they're able to look at the video footage of 89 hours and go through and say, hey, let's look at where these animals went. So they had 8 animals, went in all different directions. And what they're out there doing is they're out there trying to get food for their newborns at their colonies. So they're going around and trying to find food, and they're going all different places. So they're going, they all went to a lot of them went to different habitats, and they saw the different habitats that were around. And because it had a GPS on it, they were able to tell where they were at any point, I believe at any point in time, or maybe it's just when they come back up to the surface. I'm not too sure about that. But it allowed them to move across, benthic habitats across more than 5,000 square kilometers of continental. What these animals were seeing as they went through. So that's always, great to see. And so I just wanted to go over in this article that I'm searching for as we go. They went through a number of different habitats, 6 benthic habitats: macroalgae reef, macroalgae meadow, bare sand, sponge and sand habitats, invertebrate reefs, and invertebrate boulders. So these are the different types of categories of benthic habitats that are in that area, and they got to see all of it, and they were able to make predictions based on these areas. They sort of were very conservative, and they only went to a small area, but based on what they saw and how far out they saw, they can make those calculations of, look, this is where, the sponge sand area is, and this is how big it is, and this is invertebrate reefs, and this is invertebrate boulder. And then they can go out and ground truth it after to see, hey, how far off are we on this? Is this where the actual location is? How big is it? Were we close in our predictions of the size? And probably that algorithm will be able to change over time. But being able to see these differences in benthic habitats and how these marine mammals go, and the marine mammals are perfect for this, and like animals like sharks are perfect because they're migratory species. Like, they move over large areas. They may not be fully migratory, they may stay in one specific area, but they move over a number of different habitats. They're not like a crab that might stay in one habitat once it reaches adulthood and never really move across like different habitats, because that's the habitat it wants to stay in. But when you have a sea lion, for instance, an Australian sea lion, you can find out where it goes. And now once you've got the mapping done, this is where, the conservation begins. You can see the areas that are used by these 8 sea lions. And then you're probably going to do more studies to find out where maybe another 8 sea lions go, or maybe even more, maybe even less. You're going to see where those tags go. You're going to see what they see. You're going to be able to find out, how diverse these habitats are, how small, how big. Are there areas where there's some that are bigger than others? Are there some that are like a lot of gradient habitats? We're going to see all of that in due time, but you get to do it without paying the expensive, bill for a remotely operated vehicle or a boat that you have to use a remotely operated vehicle on, or even a drone to be able to, if you can see these habitats, depending on how deep they are, to take a boat that you have to take when you're over the water, because for a drone, because you have to be near the remote control or near the drone when you're flying. So there's only a certain range you can fly off the coast. You have to have a boat. Boats are really expensive. Gas is really expensive. And not every organization or researcher can afford that. It's not very little can afford that, especially the boats that would be required to operate like a remotely operated vehicle. So this is it's kind of fun to see like ecologists and conservationists to use an animal to say, hey, buddy, where do you go? Let me know where you go, and I'm going to try and protect that. So let's work together on this. And essentially, these sea lions are protecting themselves, which is great to see. That's what we want to see in the future. That's how we always want to see it. And so I feel like that's where we need to go and use these types of techniques, as long as they're safe for the animals. But you want to find out where these animals are going, especially animals that will cross a number of different habitats. This could be an important precedent to set and look for conservation and exploration of different habitats when you have these types of tags. Now, it's not going to be easy. There could be a lot of problems with tags. The glue may not hold. It may pop off a little earlier. Obviously, you don't want to harm the animal in any shape or form, so you have to follow specific protocols. Those change all the time, so making sure you stay up to date on those protocols. But the real frustration is if the camera doesn't work when you get down there, or maybe it gets scratched, or maybe the sea lion hits up against a rock and that goes flying, or you lose it. There's a lot of, it's not an easy thing to do. It's not you just stick it on the back and wait for the animal to come back and then you do it. And that's how they got the tags, by the way, is they'd wait till the animals came back, the mothers came back to feed their young, and they would grab the cameras off of them. They would probably sedate them. There's a picture on here. There's actually a video on here about where they go. It's really cool. I highly recommend you look at the link that I'm going to put in the show notes. But they also have to, sedate the animal, because it's going to protect itself. It doesn't know what you're trying to do. It doesn't know you're trying to help it. And so you have to sedate the animal, take that off. And so that's a process, and that's going to take a little time. And to make sure you map all these habitats using these animals takes a lot of time, but you have to remember they are animals, and they need to be protected, and they need to be treated properly. And that's what these researchers are probably doing. I hope. I pretty much know, because they have to follow specific protocols when dealing marine mammals and permitting and everything. And so we're seeing that being taken care of, and hopefully, in the future that will continue to get better and better, and more animals will be able to tell us where they go, and we can better protect them. So that's it. That's the episode for today. I thought it was a fun article to go over. I'm going to put, like I said, I'm going to put the link in the show notes. There's a great video that I'll point you to on YouTube and in the article, and you can go and take a look at that. That was on phys.org, a great site where I get a lot of my articles that I put on my newsletter, which you can sign up for if you go to speakupforblue.com/newsletter. You get a lot of these stories. I actually put the story in earlier in the week in one of those newsletters, but now I'm talking about it because I thought it was so interesting. I read my own newsletters too, but in those newsletters, I send them out Monday to Friday. I put in 3 articles, I put in 3 jobs, and I put in the latest podcast episodes that have been out on our network of the Speak Up for Blue network. And I just like to interact with you guys. So let me know what you think when you sign up, what you think of those newsletters. And I work hard on them. I try and get them. It takes me about half hour to an hour every day to work on those. So that's 5 hours a week that I don't usually have. So I put them up on LinkedIn as well. So if you want to subscribe to my newsletter on LinkedIn, you can do so. But anyway, that's it for today's episode. I want to thank you so much for joining me on this episode of the How to Protect the Ocean podcast. Have a great day. We'll talk to you next time, and happy conservation.